Later on in this chapter, we're going to talk more about solving exponential equations, but a quick introduction to it. And this is just one way to solve exponential equations. And it's a special situation. You must be able to have the same base on both sides to do it this way. So again, we're going to talk about this later in the chapter, but this is just a quick intro. If you had to solve for x and you had 1/3 to the x equals 81, you see that you could write both sides as a power of 3. 1/3 could be rewritten as 3 to the negative 1, and 81 could be written as 3 to the 4th. Now, when you have a power to a power, what do you do to the exponents? You multiply, so negative 1 times x would give you negative x. So 3 to the negative x equals 3 to the 4. Go back up to the pink. You have the same bases on each side. If you have a to the m equals a to the n, what do you know about m and n? They better be the same, right? If a to the m equals a to the n, you better know that m has to equal n. So yesterday's class said, so you can kind of just go like that to the bases? Yes. If you have the same base on both sides, and you can write it as a to the m equals a to the n, you know that the exponents have to be equal. All right, down on your first example, if you know that 3 to the negative x equals 3 to the 4, what have to be equal? The exponents. So you get to say that negative x equals 4. So what is x equal to? Negative 4. You're done. Do you know how to check that on your calculator? Okay, go to your calculator. Go to your home screen. I'm going to clear everything out for you so you can see my keystrokes. I'm going to store negative 4 for x. Negative 4 store as x. That's what I got for my answer, correct? Right. Now I want to type in the equation. 1/3 raised to the power of x, arrow back down to the bottom, and I want to say, is that equal to 81? Do you remember how you get equal to? Second test and number 1. So all I did was store my answer for x, and I typed in the original equation, yes? When I hit enter, if I get 1, that means that is a true statement. If I had gotten 0, that would mean that that answer did not work. For example, if I typed in 2 for x, and then I typed in my equation, should I get a 1? Nope. I'm going to get a 0. So 1 means true, 0 means false. You want me to go put that on the, yeah.
Mine doesn't show 1 and 0, it just shows true or false.
It says true or false?
Mine just shows 81.
Wow. So you've got a newer operating system than I do on mine. Yours, if it says true or false?
Yes, it's true or false.
Neat.
Is that better?
I mean, it's I would say that's better.
That's better. You don't have to remember that 1 means true and 0 means false. Cool. All right, let's go do number 2. 2 to the x plus 4 equals 8 to the x minus 6. What base do you want both sides to be? Base 2? What is 8? 2 to the 3rd. Okay, so I can write 2 to the x plus 4 8 is going to be 2 cubed to the x minus 6. Again, what do you do when you have a power to a power? What do you do to the exponents? You multiply them. So I have 2 to the x plus 4 equals 2 to the 3 times x minus 6. I have the same base on both sides. I just cover them up. I go like that. So I have x plus 4 equals, is it okay if I distribute that now? Equals 3x minus 18. Subtract x from both sides. I get 4 equals 2x minus 18. Add 18 to both sides. 22 equals 2x. So x equals 11. Old school calculator. I store 11 as x. And then I typed in my original equation. 2 to the x plus 4 equals 8 to the x minus 6. And what did it spit out? It spit out 1, which meant true. So my answer is correct. X equals 11. If it had spit out a 0, that would have meant false. My answer would have been wrong. I need to go rework it. Okay, quick lesson on this stuff. Do you see now that if you have a calculator in your hand and you have a multiple choice test that says to solve for something, you store in your first answer choice, you type in your equation. If you get 1, you're done, move on. That's the right answer. If you get 0, you store in your second answer choice. You type in your equation and see if it's true or false. You don't even have to know how to solve equations on a multiple choice test if you're given a calculator. I would deny telling you that to my grave, but it's on recording.
So is that just going to be multiple choice?
I don't give multiple choice tests in my math classes, no. But standardized tests like the SAT, the GRE, they do. The TSI. I want you to see an example like number 3 because let's go do let's go do a 3B first. If I were to tell you to solve x squared equals 81, what do you guys want to do? Square root, right? But I'm going to tell you, you're no longer doing the radical symbols. You're going to have to use fraction exponents. The square root is the same as saying that the square root of a is a to the 1/2, right? Okay, so instead of saying take the square root of both sides, say raise both sides to the power of 1/2. And you have to know that to put the plus or the minus out front on the right, correct? So what is x to the 2 to the 1/2 power? What does that become? X to the 1, because 2 times 1/2 is 1. And you get plus or minus, the square root of 81 is 9. Okay, let's go do this same concept over here. If I want to get x by itself on both sides, and I'm doing x to the 4/3, what power do I need to raise both sides to? To the 3/4 power. If I do that, 4/3 times 3/4 is 1. Now, what is 81 to the 3/4 power? And most of you go like this. 81 to the 3/4 power is 27. If you wanted to do it by hand, you're looking for the 4th root of 81, and then you want to cube it. The fourth root of 81 is 3. Why is the fourth root of 81 3? 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the fourth is 81. And so the fourth root of 81 is 3. Okay, so you found the fourth root of 81. Now you want to cube it. And so 3 cubed is 27. Say it again. You don't put plus or minus on this one because you're no, you don't. You're not taking a square root. Yep, I did over here because you were taking a square root. This one you're not taking a square root. You're taking a 3/4 root. Or a fourth root. And then cubing it. Go amend. Looking on the calculator, the question was asked, why do you not put plus or minus? And on this one you do. And why do you? Because you're taking a fourth root. Anytime you take an even root, you have to put plus or minus on the right-hand side. That's the rule. So on the right here, you should have written plus or minus right here. So your answer is going to be x equals plus or minus 27. And on the calculator, if you go look, if I write in negative 27 for x and I type in my original equation, I got true. If I typed in positive 27 for my x and typed in the original equation, I got true. So again, the reason why, if you take an even root of both sides, that's when you put plus or minus out front. Got it? Great question.